So we're going to go over how to calculate objects that are being thrown. This is very similar to the last assignment that we did, but if you can see here, so this is going to go on the right side of your notes, okay? Now, as you guys can see, there's actually 4 different formulas. It's nothing you can't do, okay? The fourth one here, the fourth step, this is the velocity formula, very first formula I showed you. Vx equals distance divided by time. And just remember, this is how I'm going to make my t's. It's the cursive t to separate the t from the plus, okay? T. Okay? This is actually the acceleration formula, but the a and the t have just been flipped, okay? This is very similar to the formula that I showed you with objects moving left and right. It's almost like the Vf squared equals Vi squared plus half AT or whatever. That formula that I showed you the first 9 weeks. If you check out your notes, it's somewhat similar, okay? The only thing that's going to change is probably this, Vy, Vx, and here where it says velocity sine, velocity cosine. Okay. Okay, so what I'm going to do is I'm going to go into one of the examples that we're going to do. And that example is, let's start off with this one, okay? Let's start off with this example. So this is going to go on the left side of your notes. So at this point, we can either pause the video to copy the problem, but here you have a ball that's launched at 4.5 meters per second at an angle of 66 degrees. It starts and lands at the same distance from the ground. What are the maximum height and its launch level and the flight time of the ball? So in order for us to do this example, let's take a look at our notes right away again. So if we look here, we're going to have to put Vy and Vx. That's one of the things that I didn't put in here. Let me put that in. Let me see if I can fit that. Well, you know what? I'll put it over here. Vy, V, that should be a V. Vx, and that should be a Y. So what I need to do here is, if I take a look at my notes, it says velocity sine, and this is theta, which is the angle. So here, let's get the velocity first. The velocity is 4.5. And this one's sine, and this one's cosine, okay? So that's this part, okay? The velocity, sine, cosine, and then this is of whatever angle they give you. So the angle that they give us was 66 degrees. That should be a little degree. Now this part should be pretty simple, because all you're going to do, let me fix that 66 there. I don't think it came out any better, but let's try one more time. Okay, well, I think it came out worse, whatever. 66, okay? So what we need to do here is when we bring up the calculator now, what you can do on your laptop is just type in calculator. See, and it gives you the calculator. When you bring up the calculator, what you want to do is, if you have just the regular standard calculator, you might just have this. When you press these little lines here, you want to open it to the scientific calculator. Okay. Now, if you have your cell phone, if you're just holding it regularly, you might have to tilt your so let's say you bring up the calculator on your cell phone, you might have to tilt the calculator like if you're watching a YouTube video, and it should expand all these other functions. Okay, so what we're gonna do here is I'm gonna enter in sine of 66. So how do I do that? Well, if I come here and I press the little arrows here, I'm going to put sine of 66. I'm going to hit equals. It might be the other way around. Let's try it the other way around. 66 sine. There we go. So that's how that works. So you have to make sure that you're also in degrees. Okay. So let me just double check that here. So 66 sine. And again, make sure that you're in degrees. There you go, degrees. Clear that out. 66 sine. So you're going to get this number and whatever number that you got when you entered in 66 sine. Now, on some calculators, you might have to put the number first and then hit sine, or you might have to press sine and it might like put little parentheses here, and then it's telling you to enter in the number, and then you might have to just close the parentheses. So try it out. If you don't get this number, it should kind of look like this, okay? If you're using like your cell phone. So on some cell phones, like I said, you might have to press 66 and then sine, or sine and then 66. So here, it looks like if you press the number first and then sine, it'll give you this number, okay? So once you have this number, you're going to hit times 4.5. And that gives me 4.11. Let me move this out of the way. And this is a velocity. Okay, I'll explain this number right now. So let me just do the other part. 66 cosine. Let's clear that out. 66, come up here, press cosine. It gives me a number, and then I'm going to multiply it by 4.5 times 4.5. And that gives me 1.8. So what this is telling me is the thing with objects when you're throwing them is they're either going to go, like for the objects that we were learning before, where we were just throwing an object just straight up. Well, that's just throwing the object straight up, right? That's just going on a y-axis, going up. But if you're throwing it at an angle like this, not only is it going up, but it's also going to the right. Okay, it's going up and at the right. So this Vy, velocity on the y-axis, this is telling me that as you throw this ball, we know how fast you originally threw it, 4.5. It's almost like an average, if you want to kind of look at it that way, okay? But more accurately, so as you throw this object, this ball is going to be rising 4.11 meters. It's rising 4.11 meters. That's how fast it's traveling, going up, but it's also going to the right, okay, Vx. It's going to the right 1.8 meters, okay? So those are the two velocities, the velocity of how fast it's climbing and how far it's going to the right, okay? So that's going to be important for the other stuff that we're doing here, okay? So now here, notice this is kind of like the formula for acceleration, but just the t and the a have been switched, okay? So here, let's kind of do that to really make those stand out and you don't get confused. All right, so now if we take a look at our formula, this I should have included VYF, VYI here, okay? So this should be VYF. Let me see if I can rewrite it. So T equals VYF minus VYI over A. I'm going to plug in my numbers, okay? So let me get my trusty calculator. Okay, so here what I'm going to use is for Vy, F, you're always going to plug in a 0 here, okay? And then we're going to plug in our velocity, the velocity that they gave us. And we're going to plug in this one, okay, 4.5. And the acceleration is always going to be gravity. Now for these problems, we're going to use, gravity is always going to be negative 9.8, okay? And that's what the formula calls for, okay? So when I divide these two numbers, I end up getting my time, 0.45. So this is telling me it's going to take 0.45 seconds for it to reach the midway point, the high point, okay? So now if we look at this part over here, if we look at our formula, this should be dy vy, okay? So dy equals vy t plus 1/2 at squared. So the distance on the y, how high up did it go? So see this vy here? We're going to use this number for vy, okay? This one. So vy should be 4.11. My time I just got 0.45 plus 1/2 a, which is negative 9.8. My time again, and I'm going to square that. Now this is really simple because it's the first thing we're going to do is multiply 4.11 times 0.45. Get the calculator here. 4.11 times 0.45, and that gives me 1.84. I'm just going to use two numbers. Okay. Now I'm going to square 0.45. 0.45 times 0.45 equals, so now that I have this, I'm going to multiply it times negative 9.8 times 9.8 negative. Okay. And then I'm going to cut that in half, divided by 2. And that gives me a negative 0.99. I'll just say 0.99. And now I'm going to add these up. 1.84, 1.84 plus negative 0.99. So 0.99 negative gets me 0.85. So this told me that the height, okay? It told me how high up it went, which was 0.85 meters. So now we're going to go into the fourth step. Now if we look at the fourth step in the notes, the fourth step is this, Vx equals dx over t. And I guess I'll try to do it over here. Okay. So Vx is going to be this number, the one that they give you. So that's 1.8. We don't know dx, but we know the time, which was 0.45. It's over here. So now we're going to multiply these two numbers, 1.8 times 0.45. And that gives me 0.81. And that should be meters. Okay. So this told us different things, okay, several different things. It told us how fast the object is going to rise, okay. It's going to rise at 4.11 meters per second. It's going to go to the right 1.8 meters per second. It told us the time that it's going to take to reach the high point. It's going to take 0.45 seconds for it to reach the high point, okay. How high up did it travel? That's this guy right here. dy equals 0.85 meters. Okay. And it also told us the distance from here to here. Okay. How far was that? And that's this one right here, dx equals 0.81 meters. Okay. I know it's a lot to take in, but we're going to do another example so that you guys can, see how this goes. So let's do another example. And let's work on this one. Okay. So this is going to be on the left side. And at this point, we can pause the video here so that you guys can copy down all the stuff that you need to copy down. But I'm going to go ahead and move on here. So if we were to have all the stuff here, we should have this. We should have all of this. And this should be Vx. Vx. And these should have a y, okay? They should have a y right there. And I just noticed on the last problem, I made a little tiny mistake, but that's okay. I'll show you where I made that little mistake here, okay? So it says an object is fired from the ground at 100 meters per second, so they give us that, at an angle of 30 degrees. So here, let me just erase this little part here and this little part. Those were the answers. You guys were not supposed to get the answers, but that's okay. So, okay. So we're going to find the horizontal and vertical components. After 2 seconds, how far has the object traveled? So here, let's just plug in all the stuff that we have here, okay? And where it says A, B, C, and D, okay? From the formulas that we're doing. So let's do this one first. Vy. So if we look at the notes, it says velocity sine of the angle, okay? So the velocity, it's right here. The velocity is this that they're giving us, 100 sine, and then of the angle. Oh, this one should be cosine. Let's fix that. This should be cosine. Okay, so now let's start off here with the calculator. So I'm gonna put in this first. You gotta put in this stuff first here if you're doing it here. So 30 sine times 100. And that gives me 50. Okay. Same thing with the second one. We're gonna put we're going backwards, okay? 30 cosine 100. So you always want to clear this. 30 cosine times 100. And that gives me 86.6. Okay. All right, so let's go in order. I know I have here the stuff written out of order. I'm gonna do this one next, okay? And in order to do this one next, if we look at the notes, I should have the T and the A reversed, okay, right here. There it is. So this should be time, and this should be acceleration, okay? So we're trying to find the time. So here, Vy, what I'm going to plug in for YF, that one's always 0, okay? Always, always, always. And Vy, we're going to use this Vy, okay? Which was 50. And that's where I made the mistake on the last example. I should have used that number. I think I used this number, okay? So if it says Vy, you're going to use that number, okay? And acceleration we know is negative 9.8. Okay. So I'm going to divide these two numbers and I get 5.1. 5.1 seconds. So it's going to take 5 seconds for it to reach the high point. So now let's do this part, okay? And if we look at the notes, it should say dy vy t. dy vy t. So yeah, that's right. Okay, so I have this right. So this vy, where do I get that vy? From right here, okay? So if it says vy, that's why all this stuff is very important, labeling, because it'll tell you where everything goes. So we're going to use these numbers, okay? 50. 50. My time I got from over here, 5.1 seconds, plus 1/2 negative 9.8, and then the time again squared. So I'm going to multiply 50 times 5.1 first. $50 times 5.1. That gives me 255. I'm going to go backwards here. 5.1 squared. 5.1 times 5.1 times 9.8. And then I'm going to cut that in half, right? Divided by 2. 127. So this should be a negative, okay? So it's negative 127. So now I'm going to do 255 plus negative 127. Negative 127. And it gives me 128. So dy equals 128 meters. Okay. And then the last part was this, Vx equals dx divided by t. So Vx, where do we get Vx from? From right here. Okay. This gets plugged in right there. Okay. So Vx was 86.6. equals dx divided by my time. Where did I get my time from? This was actually time right here, okay, 5.1 seconds. I'm going to cross multiply 86.6 times 5.1, and that gives me 441 meters. Okay. So this told us several things, okay? This told us what would we do if we threw this object and we have the velocity and the angle, and we know that it's climbing at 50 meters per second. That's how fast it's going up. It's going to the right 86.6 meters per second. We know it's going to take 5 seconds for it to reach the high point. How high up did it go? This high, 128 meters. That's dy. dy equals 128. How far did it go from here to there, to the midway point? And that's this one, 441. Okay, so dx equals 441. Now, if they asked you after 2 seconds, how far did the object travel? So if we look at this example here, at the high point, the midway point here, it took 5 seconds, right? 5 seconds here. So where would 2 seconds be about? Would 2 seconds be on the right or on the left? And 2 seconds, like this would probably be around halfway, right? So 2 seconds would be around here, okay? Now in some problems, they might ask you, well, find the height here and the distance from there. So how do you do that? Well, it's the same way, okay? So at 2 seconds, here, I'm gonna erase this stuff so that I can make some room. Let me erase this part right here. Okay. Now that I should have erased the half part, but that's okay. That should say 1/2. Now, if we wanted to find at 2 seconds, how do we do that? Well, we would plug in 2 seconds for the times, okay? And this should be Vy. So Vy, we're going to use the same number, 50, but this time we would use 2 seconds. Negative 9.8 and 2 seconds squared, okay? So here, let me try solving this for you. 50 times 2 is 100 plus 2 squared is 4 times 9.8 divided by 2 gives me negative 19.6, because the a should be negative, okay? 19.6. So then I'm going to add those two numbers up. 100 plus negative, I shouldn't do that, so it should be 100. Let me clear it again. 100 plus should be 19. Oh my gosh. 100 plus 19.6 negative gets me 80.4. I should just say meters. Not meters per second, because this is a height, okay? So how high up did it go here? We know it went 80 meters high, okay? If we want to find the distance from there to there, we're just going to use step number 4, which is Vx equals dx over time. So Vx, we're using the same number here, okay, which is 86.6, but all you're going to replace this is just the number. See that? Okay. So 86.6 times 2. Let's get that. 173. Okay. So that's for the distance from there to there. We're going to do one more example. And the example that we're going to do is over here. This is going to be on the left side of your notes. And you're going to have to pause the video here so you can copy these down, as we're going to just move into this, okay? Okay, so we know that a student is throwing a baseball. We know how fast it's going and the angle, okay? So let's plug in our formulas and let's kind of go from there. So this should be Vy and Vx. So if we look at our notes, you can see up here, it's velocity sine of the angle. So the velocity is 25 sine, velocity cosine, and the angle is 60. Now you'd be surprised as to how much you remember doing these. So I know it seems like a lot of stuff, but you see that it starts flowing easier. So here we're going to go backwards. 60 sine times 25, 21.6. The other one is 60 cosine times 25. Right, 60 cosine times 25, 12.5. Okay. So now over here, we're going to plug in our Vy. And this should say A here. Okay. So Vyf is 0. That's always 0, okay? This is the one that you're going to plug in, Vyi, which is this one, okay? 21.6. Acceleration, 21.6 divided by 9.8 is 2.2. So it's going to take 2 seconds for it to reach the high point, okay? So now over here, Vy, where do we get Vy from? From right here, okay? 21.6. My time plus 1/2, negative 9.8, that's always negative, squared. Okay. So now we solve all this stuff here. 21.6 times 2.2 times 2.2, 47.5. And here I'm going to go, I like to go backwards. I mean, you can go the other way if you want, but just when I'm putting it in the calculator, it's easier for me to do that because of this square part. So 2.2 squared times 2.2 times 9.8 divided by 2, right? Cut that in half, and that's 23.7. Be a negative. And I'm going to add 47.52 47.52 plus 23.7, and that's a negative, gets me 23.8. So how high up did it go? 23.8. We want to find the distance from here to here. That's Vx. Where do we get Vx from? Right there. Vx is 12.5. My time. So now I'm going to multiply those two numbers. And I get 27.5. Okay. Now, if we wanted to find, so it took half the distance to get there, right? So that's 27.5. So what would be the full distance? Well, if we know that this is 27.5, if we were to just multiply that by 2, we would get the total distance, right? So from here to here, halfway is 27.5. So from here to here, if we multiply this by 2, if we multiply it by 2 times 2, we get 55 for the total. Okay. It just makes sense, right? From here to here, that's half, 27.5. So plus another 27.5, that would be 55. Okay, so that's the total. Now I want you to notice here, they want us to find the time at 3 seconds. So 2 seconds would be around here. So 3 seconds would be around over here, right? So if we wanted to find the height here, let's do that. Okay, we're gonna do that. I'm gonna see if I can have room over here. Let's try doing that. Let me erase it and let's make some room up here. So dy equals vyt plus 1/2 at squared. So vy is always going to be these. You're always going to use these numbers, okay? It's 21.6. The only thing that you're really replacing is the time. I mean, that's it. 3 seconds. See that? The time, 3 seconds. Plus negative 9.8. 3 seconds. So 21.6 times 3. Gives me 64.8. So we can make that a little better. Plus, and I like to go backwards here, 3 squared, 3 times 3. 3 times 3 times 9.8 divided by 2. 44.1, and that should be a negative because of that negative, right? 44.1 negative. And now I'm going to add 64.8 plus negative 44.1. .8 plus negative 44.1. 44.1 negative. Gets me 20.4. Okay. And if we want to find the distance from here to here, this is like a super short one, a super short problem there, because we're going to use Vx 12.5, which is there. Dx equals, we're just replacing the time, right? The time, it's at 3 seconds. So what do I do there? I multiply 12.5 times 3. And that gives me 37.5 equals dx. So yeah, we covered a lot, right? So here, this part is telling you how fast the ball is climbing, going up. It's traveling 21.6 meters per second going up. To the right, it's going 12.5. We know that it's going to take 2.2 seconds for it to reach the midpoint. How high up is the midpoint? That's your dy, right? This part is our dy. That's our height. How high is that? 23.8 meters, okay? And how far is it from here to here? That's our dx, okay? Dx should be an x right there. This is 27.5, okay? So from here to here, that's dx, okay? Now, if we wanted to find at 3 seconds the height, we just replace the time by 3. That's it. The vy's are going to stay the same, okay? And the vx's for here. So the height from here to here was 44.1. And I'm sorry, 20.4. That was the answer over here. Okay, 20.4. The distance from here to here, that's our Vx, our dx, distance on the x-axis, 37.5. And we can do that for anything. Okay, so we know that it's 2.2 seconds for it to reach here. What would be the total? So if that's halfway, so it's 2.2 seconds to reach the half point, another 2.2 seconds to reach over here. So that's a total of 4.4 seconds. The distance from here to here we said was 27.5. If we add another 27.5 to that, that would be the total here, which was 55, right? If we wanted to find the distance here at 1 second, we can do that. We're just going to replace here the time with 1 second and the time over here. If we wanted to do it over here, it's the same thing, okay? So we can find the heights in any point we want just by replacing the time, but you do need to have steps 1 and 2 complete. And then steps 3 and 4 from the notes. So steps 1 and 2 have to be complete. Like there's no way around that. Then 3 and 4, literally all you are doing is replacing the time by the time that you want, okay? But there we go. So this is our trajectories, okay?